So we'll be working on lesson 5 today. This covers data types, operators, and expressions. So the first thing that you really need to understand about how computer programming works, or how a computer program works, is that when we double click on an executable file to get our computer program running, what the operating system does is it creates what's called a process in memory. And that process is an isolated area of memory just for that program to load all of its code, its source code, or its machine code into. And so then the CPU will start taking information then from that area of memory and loading it onto another configuration in memory, which is called the stack. And it's on the stack that the CPU then begins processing each line of instruction one by one. And the reason that we need to know that is because we need to understand that as programmers, when we're writing our source code, we will be writing code that requires certain pieces of information to be stored in memory. And so you'll need to know how to go about doing that and all the particulars that are involved in identifying how much memory is needed for the storage of particular items that need to be stored there in memory. And so you probably heard this term variables before. And so that's kind of the overarching concept of what we're learning in this lesson here, is basically how to create and use variables in our program. And so we've got a little video here to get started this morning. Let me scroll down. Oh, I'm still in that mode there. Okay, so let me scroll down to here. And I guess actually the video was a little bit further down. So let me just go through some of the explanations here. So a variable is, just think of it as an area of memory that you can store information into, you can store data into. And then in order to retrieve the data that we're storing in memory, we use what's called an identifier or a name. And so that's really what the variable is the name and then the area of memory that name represents where values and data are being stored. So we need to, in our programs, tell the compiler that we intend to create these objects, these variables, and that process is referred to as declaring a variable. And so I'll show an example of that here in just a little bit. But when we're declaring the variable, it's just a simple line of code that says that, we want to create a new variable and we're going to call it X. And so that kind of starts the process. That identifies to the compiler that we're going to have a reference called X here in a little bit. And that reference is going to be an area of memory where we're going to store data into. So that's the declaration of a variable. And that's the first stage of the creation of any variable. The second part of it is what we call initializing the variable. Initializing refers to the fact that we're actually assigning some sort of a value to that variable. So when we declare it, we're just declaring our intentions to have a variable of a certain name, but we really haven't at that point put anything into memory that is the data that's going to be stored there. It's not until you initialize the variable, meaning assign a value to it, that value, that data then actually gets recorded, stored into memory. So declaring a variable just basically is telling the compiler, here's a name that we're going to use, it's going to be a variable. Initializing gives more information to the compiler, basically says, here's the actual data that you want to store in memory. Now, part of this process of creating these variables, both declaring it and initializing, and more from the declaration side of things, in modern computer languages, there's kind of two different ways of telling the compiler how much memory we need for a particular variable. So there are dynamically typed languages like JavaScript and Python, which aren't quite as particular about the size of the area of memory that we need to store information into. What it does, those programming languages, they dynamically, meaning as the compiler is running, it will actually notice what values you're assigning to those variables, and it will determine how much memory is needed for them. Those types of programming languages are a lot easier for beginning programmers, but the end result is they can be problematic because you may end up with a value stored in memory that's not quite in the format that you expect it to be in. So the languages that are like C++ and C#, those languages are what we call strictly typed languages, meaning that when we're creating these variables, we will also need to tell the compiler how much memory it needs to reserve to store the data for that variable, the values for that variable. And that's when we get to data. That's what data types are all about. Data types are things like integer, char, C-H-A-R, bool, which represents Boolean values, meaning essentially binary values, can be true or false, strings. Those are the data types. And so let's go down where you can see some examples, and it'll make a little bit more sense, I think. So right in here, you can see that in this example that I'm showing you, we've got the data type listed first. INT represents that we want to create a spot in memory, an area in memory that can hold an integer. And so that is the data type. That's followed then by the name that we want to assign to our variable, in this case, age. And then in this particular case, we're actually initializing the variable at the same time that we're declaring it. So we're using this equal symbol, which is called the assignment operator. And we're assigning the value here on the right, 23, to that variable age. And since we told the compiler that it's going to be an integer, it knew how many bits in memory to reserve to store that value. So that's what data typing is about, is identifying how much space is necessary to hold that data. So if we go back up here now, you'll see I've broken down the data types by programming languages. They vary between C++ and JavaScript and Python and C#. So the main thing you need to understand here is that when we're talking about JavaScript or Python, those are dynamically typed. And so you'll see that they don't have as many specific data types as these other languages here, like C# and C++. And that's just because they're more versatile, but in the same respect, they're also more wasteful, because you'll end up having areas of memory that are actually larger than necessary to store the data. And so we're not being as efficient in those languages. Now, JavaScript actually has a newer kind of brother, I guess you could call it, out there. It's called Typescript. And that is an actually strictly data typed version of JavaScript. As we get into this more and more, you'll see that, again, for beginning computing, languages like JavaScript and Python are a lot easier, because you can just use a keyword var just to say, hey, I want to create a variable. It doesn't matter what type it is. I'm indicating to the compiler or the interpreter in the case of JavaScript that it's going to be a variable, but I'm not telling it the type. And so once we assign a value to it, then the compiler or the interpreter will infer, they call it, what the actual data type is based on the value that's being assigned to it. And so if we go back down to the C# table that I have for you, and all of these have links that you can use to get to other tables for these languages. But since in this class I focus mainly on C#, I've got the table right here for you. So you can see that the idea is that the data type, these names that we see here in this left-hand column, actually define then to the compiler how much memory, what the size in memory is going to be if we're going to store a value of that type in memory. So in the case of a byte, as you might assume, that's going to be 8 bits. So it takes that much area of memory to be able to record a data value of a byte into memory. 8 bits. And as we talked last week, when we were looking at the binary conversions there, we have 2 to the 8th power. That gives us the possibility of 0 to 255 or 256 total values. So anytime that you want to write out a number from 0 to 255, you could store it in a byte. The next one that you see there is the char. So the char then is the individual character itself. So again, think back to last week when I was showing you that Ascii table and how the Ascii table then had all those numeric representations. So remember this table here, the Ascii table, American Standard Code for Information and Interchange. Remember that was the first set, the character set, encoding set that we had in computers. And so these were the values from 0 through 127. And in this left-hand column, we have the decimal representation of them. Then the second column is the octal, meaning base 8 representation, then the hex, base 16, and binary, base 2. So all the various numbering systems that we might be encounter as programmers, for the most part, you'll work in probably hexadecimal or decimal. But then even in when I'm doing markup code like HTML, we have various coding symbols here that we can use to represent those characters as well. But from a programming standpoint, we focus more on the decimal values and the hexadecimal values. And the reason they use hexadecimal so much is because remember, we're organizing bits into groups of 8. And so hexadecimal is base 16. So when we want to work with groups of 8, that is a numbering system that works very well for that. All right, so just reminding you that these are numeric values, and they're all going to eventually be translated into binary, right, when we convert it all down to machine level. And so that's just the ways of representing all the different characters and symbols then that we can portray from a particular language. So this here, and we'll get into this a little bit later on, I got a section on chars in this tutorial, but it's identifying for you that if you want to do Unicode characters, they're just representing that goes from 000 all the way up to FFFF. This F is the number 15 in the hexadecimal numbering system. It's like our 9 in the decimal system. Underneath of char, you'll see that we have a grouping then of numeric values. So you have shorts and ints and longs. And then we'll get into floats and doubles as well. But shorts, ints, and longs are 4 integers. So remember that an integer is a numeric value that doesn't have decimal places. So if I only want to have a small integer value, I could use a short as my data type. You can see that would just have 8 bits, or I should say 16 bits, 2 bytes being used there. So that gives you a range then of negative 32,768 all the way up to positive 32,767. Then integers, they use 4 bytes of memory. And so we get much larger values when we use an int data type. And if that's not enough, we could even go to a long, which uses 8 bytes of memory. And you can see we're getting up to very, very, very large numbers at that point. So a short and int and a long are just different integer types, each one having a different size, right, that it's capable of storing for the data that we're actually going to put in there. So short's going to give me a much shorter range of numbers. Integer gives me pretty decent, up to 2 billion on both ends, positive and negative. And then longs give us, if we're doing astronomical numbers, we can get into longs. And there's even bigger numbers than that, but these are the ones that are most commonly used. But again, the main, I think, focus there would be just realize they don't have decimal places. And most commonly you would use int. If you're in an environment where you're really concerned about memory usage, then you would be consider using a short because you want to be more efficient in the usage of your memory perhaps. Then after those integer types, then we get to the decimal types. So we got float and we got double. So again, just different sizes of numbers. These numbers can contain decimal places. So we have 4 bytes for a float, gives us the ability to do 1.5 times 10 to the 45th power, all the way up to 3.4 times 1038, whatever those numbers are. And then double, 8 bytes there, so you can see again, even larger numbers if we use a double. So it really comes down to efficiency. Do I want to do I not really care? You know, I could use doubles all day long, but if I have some concerns, like maybe on mobile devices, there's not quite as much memory available as we usually find on like a desktop system, then, you know, I'd be better off probably using floats. But there might be reasons to use doubles. Maybe I need numbers, you know, larger than a float can handle too. So that's the decision-making process, you know, that you use to determine what's appropriate for your particular code. Boolean, we can use that to represent true, false, up, down, left, right, you know, anything that's binary in its nature. So they actually use 2 bytes to store a Boolean value. And then the last thing there that they show you is a string, and there's no size. Strings are unlimited. In fact, another aspect of variables that we'll talk about as we go along, in fact, it's talked about right underneath this table here, is value types and reference types. So the first 1, 2, 3, 4, 5, 6, 7, 8 data types that you see in that table, all of them before string, those are all what we call value types, meaning that the actual data value that's being stored in memory is not in that general area of memory that we were talking about earlier where your program is stored. That's called the heap. Value types get placed right onto what we call the stack. And so the stack is where the actual instruction set resides that the processor goes through from the very first item in the stack, and then it pops that off once it completes it and goes to the next item in the stack. That's where all the instructions are. We call it the instruction set. And so as these variables are being created, those first ones, all the ones up to string, their actual values for the data get stored on the stack. So if I have x equal to 9 and it's an int, I'll find that that value is on the stack. It's not in the heap. This isn't going to be important to us for the most of our programming because we won't get into more complex data types where you'll create your own examples of things like strings. And so complex data types, strings included, actually get stored into the heap because they need more room than what we see here with these other data types. So a string is actually a data type that's called an array. And an array is a way of creating a variable where you assign a single name that represents lots of values. So you can have my array, and my array position index 0 would have one value, and then my array index 1 would have another value. My array index 2 has another value. So these index locations within that object, within that data type, each location referred to as an index or an element, they each would have their own values. So a string really is an array of chars, those individual character types that we looked at in the Ascii table. So anytime you type out like your hello universe in your first assignment there and you put it between quotes, that was a string data type. The way it was actually stored in, excuse me, it's stored in memory was as individual characters. Go ahead. I heard somebody asking a question.
I have one real quick. Can you say again the kind of, you explained arrays really well and I didn't quite get a chance to write it down. Can you say that again?
Well, an array is a variable that you assign a single name to, but it can contain multiple values.
Okay.
And it depends on the language that we're working in. Like in C#, your arrays have to be, all the values in that array have to be of the same data type. So if you think about a string, it is an array of chars, and so that means that each value in that string is a char, so they're all the same data type. However, JavaScript, it's more flexible, and when you create arrays there, you can mix dates with integers, with chars, with bools. You could have all different data types within each of the elements in there. So the language, the programming language you're using is going to determine whether or not that array is forced to have only a single data type of values or if they can have varying data types of values.
Okay.
For C#, just know that it'll always be the same data type within an array. And we will get to arrays in this class. That's the first complex object that we really teach in most programming languages. And so that's kind of the last thing that we get to in this class. So just for now, you can kind of stick that in the back of your head that a string is a data type, but the reality is it's just a collection of chars. That's how it actually gets stored in memory. And the actual name of that structure is called an array. And then just re-emphasizing this concept of value types and reference types. So value type means that if I were to look at this stack, and so picture a stack as, if we're using a 64-bit CPU, the very first row in the stack is 64 bits wide. So the CPU determines what the width of the stack is, how many bits can be placed in each entry of the stack. So a stack is just an object that is capable of collecting, again, in a 64-bit system, it would have line after line after line of 64-bit instructions in there. Part of those instructions will be the declaration and then later the initialization of your variables. And so if they are, the data types are all value types, you'll actually be able to see in the stack, if you were to be debugging mode at that point and looking at the values as your program is running, you could actually see those values sitting on the stack there. And it would say that X is this value, 3, 6, 9, 120, whatever it is. The char is a letter A, or whatever the sequence of zeros and ones are that make up the letter A. Those are actually going to be on the stack. But the string and arrays and all these more complex data types, which we've talked a little bit about object-oriented programming. In object-oriented programming, you make classes. So when you're creating classes, you are creating your own custom data types, and those are also complex data types. So they're referred to as a reference type because there's the data is, there's so much information there that you can't just store it in a single line in the stack. So what the stack contains instead is a pointer to where to find the data in the heap. So for a string, it's actually putting in a memory address on the stack. And it's that memory address then that points over to the heap and says, here's where that string begins. And that would be true of classes and other complex data types. We'll see a few other complex data types in this class. So in fact, we'll actually look at stacks and queues and things of that nature, I think, in the next chapter, next lesson. But for the most part, we're focused on these simple data types, these value data types. We'll be working mainly with string, well, except for string, because string is a very common thing to use in programming. But we'll use an int here and there. And I don't think we really, I'm thinking ahead here at the assignments, I don't think we really actually use any of the other data types other than the ints in the string. And then the other thing too that we'll see a little bit later on is that in these strictly typed languages where we do assign values to a specific data type, there will be a need at some point where we might have to convert our value that we've stored in one data type, convert that to a different data type. Most common example is when you're accepting input from the user from the keyboard always comes in as char values. So if you want to use, say, you ask the user to type in, to type in a number, even though they put in 12 from their keyboard, the way that the processor is seeing that is that came in as the char that represents the number 1 and then the char value that represents the number 2. You know, that's how it's actually being represented in memory there. So we'll have to convert those, obviously, right? If they're chars to, if we want to use them in mathematical problems, then we'd have to convert those to ints or doubles or, you know, whatever's necessary. Or go the other way. You know, it might be that we have a numeric value, but we need to output it to the screen as string. So conversion is something else that we'll go through. So getting back to this basic concept of what a variable is, again, this is the graphic that says, you know, you're going to create some sort of, you know, this is how we kind of picture it. We're saying we're creating an identifier that's a box. And in that box, we're going to put a value. So that's kind of how we represent our variables. But again, just remember that based on the data type, if it's a value type, it's going to be stored, that value stored on the stack. and it has an identifier with the value. And if it's a reference type, that just the memory address of where it's stored in memory is stored on the stack. So again, declaring the variable is just simply identifying to the compiler or the interpreter that we have this intention to have a particular variable of a certain name. So let me get back to my highlighter here now so I can emphasize some of this for you. Where'd it go? There we go. All right, so right here is where I'm at. See, this is a declaration. So what we've done there is just said, hey, here's my data type int, and I want the name or identifier. You can use those interchangeably. We want to call it age, and then it's a statement. So we always, in C#, we end it with a semicolon. Back when I was writing this here, we were still dealing with a 32-bit system, so it talks about 32-bit ints at this point. In fact, if we go up here, we can see actually an integer is still a 32-bit data type. So 4 bytes, remember that a byte is 8 bits, right? So 4 times 8, 32. So that is still correct. The integer is 32 bits. A little further down, just showing you that in the C# language, there's this method that's built into all of these value types. It's called the getType method. And so anytime that you create a variable, if later on in your program you need to test and see what data type it is, you can use that method right there. So the way that the way it works is your variable name would be on the left there, followed by a dot, and then getType with parentheses. And then again, it's a statement, so we end it with a semicolon. So that's just a way of getting the actual data type. Is it an int? Is it a string? Is it a char? You know, what is it? That's what would be returned from that method as a value. Okay, so up above we were declaring the variable. Now down here you can see that we're initializing the variable. So you have to think about this one. This could occur in 1 step, or this could occur in 2 steps. So in this example here, it's being done in 1 step. We're both declaring it and initializing it at the same time. So we're identifying the data type because we're using C#. So we're identifying the data type. Here's the name, the assignment operator, which is the equal symbol, and then the value to the right of the equal symbol gets assigned to that identifier there on the left. Again, it's a statement, so we end it with the semicolon. Whereas down here, we would use this expression if we had already declared our integer of age. So up above where we showed you, we just do int age, then that would declare age, but it hasn't assigned a value to it, so it hadn't been initialized yet. So here what we've done is after it's been declared, we've just gone back and assigned a value to it. And that's basically how you would change your variables as you're writing your code. If throughout your code, you'll just take that variable name and assign a new value to it based on certain calculations or results or whatever's going on in your program. As far as variable names, you got to make sure that when you write out those names that you don't start with a number. So any letter, any underscore, that's a character that can be used to start the name of a variable. You can include numbers within your variable, but just you can't begin the name of a variable with a number. Let me clear that. So then down here now, we're showing you the difference between implicitly typed and explicitly typed. So C#, we have to declare the data type. In JavaScript and Python, it's implied just based on the value that's being assigned to the variable. So they use, in that language, the keyword var. In fact, actually, JavaScript recently created a new variable or new keyword called let that also allows us to define, declare, and initialize new variables. And I won't get too deep in that, but just var basically means that it's going to be a global variable, can be used throughout the program. Let means it's a local variable, it can only be used within the structure, like the method or the function that it was declared in. You don't have to worry about that too much at this point, but just, again, it's just stuff you need to stick in the back of your head. You're going to encounter it as you go down the road. So here, just type, in Python language, there is a type function. So you can see in that particular case, you do type and then you stick the variable name inside of the parentheses. And so Python would just return what the data type is in that case. Here, yeah, I just updated this actually yesterday to also include the word let in there. So that was at this is the latest release of JavaScript, ECMA script version 6. And so that's when they added that let keyword in there. But it's still a dynamically typed language. And so just examples of var age equals 20 or let age equals 20 gets the same results. It's just kind of how they're able to be used by other components within your program is what that's dictating. That's the global and local aspects of those variables. We'll get to that later. All right, so now we're down to that video that just kind of gives you a nice overview of variables and kind of shows you how they work. It'll repeat a lot of what we talked about here, which is good to reiterate concepts.
As soon as we write even the simplest program in any programming language, we have to keep track of pieces of information. If we're building a loan calculator, we'd need to keep track of the amount of the loan, the number of months, the interest rate. If we're writing a game program, we might need to know the current score, the position of the player on the screen, how many lives do we have left, what image do we use for our player. This is all data, and we create variables to hold that data. Variables are simply containers. What we're doing is going out to the computer memory and grabbing a little piece of it, giving it a name to use while our program is running. We grab this space and we name it, and then we put a value in it, like an email address or a date or a position or a number, and then we can change that value as we need to. Variables can vary, hence the name. So in JavaScript, you create a variable like this. The word var, written all lowercase, which is part of the JavaScript language. And then we name the variable. The name of the variable is up to us, and it should represent the piece of data that we want to hold. So a variable called year, or one called customer email, or today's date, or while we're experimenting, just nonsense words like foo, or even a single letter like X. Now, the name that you use for your variable must be written as one word. There are no spaces allowed, and it can be made of letters, numbers, the $, and the underscore. No other characters are allowed, but you can't actually start with a number. So this variable name, for example, would not work, but reversing them so the number's at the end, that would work. Now, we'll talk more about naming our variables later on when we talk about style guidelines, but I'm just going to use simple names for now. Now, all we're doing when we create a variable is carving out a little area of memory to hold a value. Now, right now, after this line of code runs, this variable exists. It has a name, year, but it doesn't have a value. This is regarded as undefined, and undefined has a special meaning in JavaScript. But there is no point to having a variable that stays undefined. So we can define or set the initial value of the variable when we create it. We could do that as two statements. I say var year, then year equals 2011. And that puts the value in the variable. Now, very important, the equals sign here is setting the variable to the value 2011. It is not a polite description. It is a command. Put the value 2011 in the variable called year. Now, you can also combine these into one statement to both define and create the variable and to set its value. Now, here's a place where JavaScript will let you be sloppy, and I won't. Now, technically, the word var is not even required. In JavaScript, if you just write a line of code like this, without var, JavaScript will go looking for an existing variable called year to put this value in, but if it doesn't find it, it will just make it. However, we are always going to use the word var when defining our variables. There are a couple of situations where leaving var off can lead to unexpected behavior, so make a habit of always using it in your JavaScript. Now, once again, JavaScript is case sensitive. That means if I create a variable called x with a lowercase x, that's 1. If I use the word uppercase X, that's 2. These are two different variables. This second line here might have been an accident. Maybe I meant to say lowercase x. But because of the automatic creation of variables without the word var, you would now have two different variables. And nothing in JavaScript would actually give you an error on this. So be careful when you're naming your variables. Now, if you're creating multiple variables at the same time, you can, of course, do them on multiple lines like this, but you can actually combine them onto one line, separating the variable names with commas. It's just a shorthand way of doing this. And similar to that, if you're actually creating multiple variables and giving them all initial values, you can still combine them onto one line. Just makes it a little easier to read, a little shorter to write. Now in JavaScript, once you've actually created a variable, you can put anything in it. Numbers, text, dates. It could start with a number, then put some text, then put a date in it. Now that might not sound unusual, but a lot of other languages don't let you do that. Creating a variable in many languages does not just mean defining a container, but also saying what type of container it is and what it can hold. And while that's not essential in JavaScript, it's really useful to know. So we're going to take a quick look at that idea.
Okay, so hopefully that helps to clarify variables for you a little bit better. He did show you the example there of being able to create multiple variables all in a single line. So you just simply put your data type out to the left. So we could use integer, and then we could have x, comma, space, y, comma, space, and z. So you'd have those three data types of integer all declared at that point in time. And you can assign the values, initialize them at the same time as well, just as long as you separate them with commas. So there's another type of a variable called a constant, which really isn't a variable. I mean, we declare it and initialize it like we do a variable, except you can see here that we use the keyword const, and that's in the C# language that we use it. It's a little bit different in other languages, but I'm pretty sure C++ uses it that way, and Java, I think, is also the same way. So const is just saying that when we create this variable, go ahead and give it the data type, give it a name, assign a value to it, but once that variable has been assigned a value, you can't change it using your program. You can't go back at a later part in your program and say, oh, okay, now we want to reassign a different value to our integer I. So once integer I has been initialized with a value, that's going to be the value for I for the entire program. You can't change it. So the idea of a constant is a lot of times you'll have things that you want to represent, like the days of the week, months of the year, things of that nature, and you want to represent them numerically. So you might go through and create those all as constant values at the beginning of your program, and then you could just use them by name, January, February, if you're doing months, and each of those names would represent the specific value that you pre-assigned to them, numeric value generally. So we're getting into the actual data types now. Going to go through some different examples for you. We can go ahead and plug these into our Visual Studio. So go ahead and do that on your computer. Get your Visual Studio open. And we'll create a new project here and solution. So once we're on our Visual Studio startup screen here, we want to go ahead and choose the bottom option on the right under the Get Started column. So go ahead and click on that Create a New Project option. It's going to be a C# console app using the .NET Core framework. So that's the choice we want to select here. And then on the next screen, let's call this first project just Bool for Boolean. And remember, when we type in a project name, it also gives us the solution name is the same. This time, I actually want you to go down and change that solution name to read variables. So we're actually creating a solution that's called variables, but what we'll do is we'll add multiple projects in here, starting with this first project, which is going to demonstrate Boolean data types. So put your project name as Bool or Boolean. It doesn't really matter. Just Bool is how it's actually referenced in the language itself. And in fact, the video brought up a good point too, that most programming languages are case sensitive. So as you're declaring these variables, you want to get in a habit of typing them out in a certain fashion so that you can recall them much easier when you go to reference them later on in your code. And so we'll talk about snake case and camel case and whatnot here in just a little bit. So if everybody has a project name of Boolean and a solution name of variables, go ahead and click on the Create button in the lower right.
Before we get started, I have
Sure.
a question.
Go right ahead, yes.
It's based off of the value of variables and constants. Some of these words are used in math. What's the difference between those and the ones we use in programming?
We're going to get to the operators a little bit further down. So yes, we're using what we grew up knowing as mathematical symbols, but like the equal sign you saw there, it's used a little bit different in programming. We're not using the equal sign to say the expression on the left is equal to what's on the right. We're actually saying, hey, this value on the left, or this variable name on the left, we need to assign a value to it. And so that's called the assignment operator in programming languages. And so there are some other combinations we'll look at. We'll get to conditional operators, logical operators, all kinds of stuff like that. So that's a little bit further down. So just kind of keep that in the back of your head. That's a good question. For the most part, like if you want to add things together, you're going to use the plus symbol. If you want to subtract values, you use the minus symbol. And then for multiplication, we use asterisk. For division, we use the /. So there are what I would call accommodations, right, that we have to make as far as our programming languages are concerned to be able to do what we need to do to get things done. And so it is a little bit different than just writing out straight mathematical formulas. So we will cover that in more depth. Is that okay?
Yes.
All right. So is everybody looking at an open program there called Boolean? And we have the basic template code using system. The namespace was assigned the name of our project, so it's Boolean. We pretty much always use the program as our class because that's the name of the file that Visual Studio creates for us. Then you have your static void main, so that's the main method that fires off whenever we run this program. And then inside we've got that default text, console.writeLine, hello world. So everybody sees that? Say no if you don't. What I'm going to do then is I'm going to tab back to the lesson that we were looking at. And I'm just going to copy all of this sample code that I have here and then paste it into Visual Studio. So when we're doing these copy and paste operations, for the most part, at least in the beginning, I know that I gave you pretty much a complete program. A little bit later on, I'll give you code that just needs to be copied and pasted into that main method. But you can see this is a complete, the only thing this one's missing is the using directive. So everything but the using directive will be able to be replaced. And I'll show you that as I do it here. So I'm just copying everything in this sample text from that first namespace, which is public class bool test, and all the way down there to the closing curly brace. Now the comment that you see under that last curly brace, that's what the output is going to be. That's the output of this program here is going to be true. Days is, and then a list either odd or a number, or odd, even or odd, there we go, as what the value is. So I'm going to copy this code, Control-C from my keyboard, switch back now to my project in Visual Studio. Like I said, we do need to have the using statement there, the using directive, but we're going to replace all the namespace code underneath of it. So the whole namespace is going away. I'm just selecting all of that and then Control-V to paste it in. So what this code is doing, it's initializing a Boolean variable that we're going to call b. That's its name, lowercase b. And we've assigned a value to it of true. So remember, Booleans can accept true or false values. So initially then we have a console write line statement, and it's going to output the value of b to text. And so in other words, it should display true on the screen. Then underneath of that line, you can see we have a new initialization here of a new variable. It's going to be of integer type. We're going to call it days. And in this case here now, we're using some of that .NET Core library. So another one of the cool objects that we have available to us as programmers from the .NET library is the date time object. And so as you might assume, that's an object that gives us the ability to utilize date and time values, and then also it will allow us to get the time from the user's clock. So that's essentially what we're doing right now. We're saying date time, use the date time object, you get the now property, which is today's date, and then convert it, just return the day of the year for us as the return value. So it runs that block of code to the right of the assignment operator, determines what the day of year is based on the user's clock, and that's the value then that gets signed into days in memory. Actually on the stack, right? Because it's an integer. So at that point, days is going to represent the day of the year, and what we want to see is it even or odd. So we come down to the next line there, underneath the comment where it says assign the result of the Boolean expression to B. We want to take that days variable, apply the modulus operator to it, and essentially divide by the number 2. Once we've completed that calculation, we want to compare the results of that. That's what the 2 equal signs represents. Again, equals will never be equals. In this case, when you use 2 equal signs, that's now what we call the comparison operator. So what we're doing is we're comparing, if we divide days modulus 2, and remember what way that modulus works is if there's a remainder, then just the remainder portion is what a modulus returns. So for instance, say that it's the 3rd day of the week. If we take 3 and we divide it by 2, we have 1 left over, right? Now compare that to say that it was the 2nd day of the week or the 4th day of the week. If it's the 2nd or the 4th day of the week, we divide by 2, we'll always have 0 left over. So that's what the point is. If it's even, then essentially, it should compare to 0. The results of the modulus operation there, right? If it's an even number, would always return 0. If it's not an even number, it won't return 0. So that's really what that expression is evaluating there. It's checking to see if days is even or odd. And in this particular case, it'll return, because remember, B is a Boolean type, it'll return true or false then, based on the results of that expression. So if it's an odd day, it'll return false to B. If it's an even day, it'll return true to B. And then in the next block of code, you see that this is your first introduction then to a logic statement. Here we're using the if keyword to evaluate what the value of B is. And so that's the way that an if statement works, or an if clause. You're essentially saying, hey, if this variable's value is true, then do what's in the parenthesis or the curly braces underneath of it there. So remember, the calculation up above is going to get one of 2 values returned to B. It'll either be true if it's an even number or false if it's odd. So you evaluate now to see, is B true? If so, then write out days is an even number. If it's odd, then it skips the if output and jumps down to the else output. So it's saying, if this is true, do this, else do this other thing, which the other thing is write out days is an odd number. So let's save the changes we made here, Control S, and then let's run it with Control F5. Now, the next thing we look at is another little program here. It's called the Bool key test. And in this example, what we're doing is we're going to have the user type in a character from the keyboard. So we'll introduce you then to this new method of the console object, which is the read object. So up to this point, you've been using the write line object, or write. In fact, I don't know if we've talked about the difference there. Previously, we used write line. In this example, I'm using write. So the difference is, if you do console.write, the cursor on the screen will be flashing right after this text here. So right here, where we have the end of that text that the user sees, the cursor would be flashing right after it. It would not move down and be underneath of that line of text. If we use write line in here instead, it prints out this text to the screen, but then it moves the cursor down one line. So that's the difference between a write line versus write. And you also have read and read line. But generally we use read to take information in from the console, from the keyboard, I mean. So in this case then, we're going to create a new char data type. It's going to be called C. And we want to bring in then the information that the user types in from the keyboard. And I have to correct myself earlier because I'd said that the value, the data type that's coming in from the keyboard were chars, and actually that's not quite true. It's actually a string data type that comes in from the keyboard. And because it is a string, and because we need to assign it as a char, we need to convert it. So we're doing a little thing here called casting, where we told that console.read method, when you get the value from the keyboard, we know it's going to be a string, but do us a favor here, convert it to a char so we can then assign it to our variable there on the left, which is C. So that's called casting. That's just one of many ways to convert data types from one to another. Very common type, very easy type when you think about it. All you do is just put the new data type in the parentheses before whatever the variable is that's listed to the right. So this is going to generate a variable for us, or I should say a data value for us, right, when the user types in something from the keyboard. So that data value needs to be converted to this data type char because it's coming in as a string. So we end up with a char then assigned to C. And then we're going to use this isLetter method then, which is built into the char object. So anytime that we get a char as a variable type, we can use this .isLetter method to test and see whether or not the variable that we have there, C, whether or not it is a letter. So did the user type in a letter? Did the user type in a number? That's what that tests for. So remember how if works. If this is called an expression. So it's if followed by parentheses, and there's an expression in there. That expression has to be evaluated. So the interpreter or compiler, that's going to evaluate that expression, determine if the results of that expression is true or false. And in an if statement, if it's true, then the compiler interpreter continues reading the lines that are inside of the curly braces that represent that if block. If it's false, it skips all of that and it jumps right down to the else statement here. So you'll notice in this case, we're doing another check after we test to see if they typed in a character or not, a letter, because they did type in a character, but was it a letter or not? Now we're checking to see is it lowercase or uppercase. So in this case, we're using the isLower method of the char object, checking our variable C to see if it is lower. So again, it's an expression that's going to be evaluated. And if it's true, then it'll write out that it is a lowercase character. If it's false, then it'll jump down here and say, nope, it's an uppercase character. So if this is true, we do all of this. If this is false, we just do this, which is saying it's a non-alphabetic character, right? Because if it's not a letter, then that's what we want to output. It's a non-alphabetic character. If it is a letter, then we want to check and see, is it lowercase or uppercase, and output that accordingly. So that's what we call a nested if statement, where you have this outer if here that has an internal if inside of it. So it's always the curly braces that determines the beginning and the ends of those blocks. So that's ifs and else will always have one or more lines of codes as a result. And those are just referred to as blocks of code. So in this particular case, just depending on what you type in, so here, example, typed in an uppercase X, so it comes out that it is an uppercase, then a lowercase x was typed in, shows it's lowercase, and then number was typed in, non-alphabetic character is the result. So let's create a new project in Visual Studio, and then let's copy all this into it and run it. So click and drag, copy all that code there, Control C, and then I'm just Alt-tabbing back to my Visual Studio. I want to create a new project. Now, we haven't done that yet for you, so follow along here. I'm going to move over to the right to my Solution Explorer. And remember that Boolean is the project we're currently looking at, and it's inside of this solution called variables. So it's to the solution now that we want to add the new project. So I want to have solution, right-click on solution, because that's where I want to add the new project. Come down to the option in the menu that reads add, and then I'll, from the flyout menu, choose new project, So again, identifying the project type, console app, .NET Core. So I just selected that template type from there, click next. You see here, all we get is a project name. So we want to call this one, what is this, our bool key test. So I'll type that in as the project name. And you can see it's still going to store that in our variable solution. Then we'll click create. And now I have a new project in my Solution Explorer called bool key test. And that's the code now that we're seeing over here on the left in the source code editor. Let me double check to see what do we have here. We just need to replace everything but using system in our template here. So I'll select all of that code, replace it from what I copied there in our lesson. And then save it, and then run it, Control F5. I'll go ahead and type in the uppercase X. Oops, what happened? Let me run that again, not sure what happened there. Control F5, uppercase X, it's closing on me right away. Why is it? Shouldn't do that. Oh, because no, if I'm running in without debugging, it shouldn't close. Oh, take a close look at my window. Man, I'm telling you, I must be sleepy this morning. What do you see as the results of in my console window? Come on, anybody. You can see that.
It's showing the day as an even number instead of...
Right. So that's our last program, our last other project, right? What we just did before this one, correct?
Yep.
Yeah.
So here's why that's doing that. Take a look over here at our Solution Explorer. And what you'll see is that project that we previously created the title is bolded. So when you see that bolded title, that's your visual clue that Visual Studio is telling you, hey, this is the currently active project in this solution. So to change that, we need to go down here to our new project, right click on its name, and then come down to this option here that reads Set as Startup Project. And you'll see that that'll change it so that that's now the bolded project name. So now when we do our Control F5, now it'll run that project. So Control F5, and now it's asking for a character. There's my upper X. So that character is uppercase. Now I'll need to close that window and we'll run it again. Control F5, type in a lowercase x. Now it tells us that's a lowercase. And then I'll run it one more time. Control F5, type in a number, and it says it's a non-alphabetic character. So that seems to be all working correctly. So now we're going to move down to the byte type. And so in this case, well, first of all, it just reminds us of the type up here. So it represents an 8-bit unsigned. So when you see that word unsigned, means that it's not negative or positive, right? They're just all positive values. A byte is an immutable value type that represents unsigned integers with values of a range from 0 all the way up to 255, because again, remember, it's 8 bits. There is another byte type that wasn't in that table up here. It is listed in the paragraph text here. It's an S byte. So if you think about the way that the byte definition reads, it reads that it's a 8-bit unsigned integer. So you can kind of hopefully think to yourself, well, maybe that S stands for signed integer, and it does. So when you have a signed integer, or a signed byte, I should say, the range is now, we can have negative numbers, so now the range is from negative 128 to positive 127. So the difference that you get, if you have an unsigned byte, you can go from 0 to 255. If you have a signed byte, you have the ability to go from negative 128 to positive 127. So you can see we can only use half of the bits for the positive side now, right? So we're only getting, 2 to the 7th, no, 2 to the, what is 127 will be, yeah, 2 to the 7th. because they actually it's the minus symbol that makes it a signed value. They're using a bit for that value. So what they did is, instead of using all 8 bits, which would give us 0 to 255, they had to use 1 bit to represent whether the sign is positive or negative. So now we're only using 7 bits. 2 to the 7th power gives us 0 to 127. Or 0 to 128, actually. No, I'm sorry, 0 to 127, 128 values, that's right. So anytime you're going to have a signed data type, usually it's going to be smaller than the unsigned data type, because you have to include that character to represent whether it's a negative value or a positive value. Or no character obviously is a positive value. So then some examples of creating some new bytes here. So we got byte value 1, we've assigned the number 64 to it, byte value 2, number 255 to it. Yeah, the byte value is an integral string, no leading zeros. There is a method that is built into the byte object if we need to convert it to a string value. So it's just the toString method. Now the other thing with the byte values, and it's talking about it here in the remaining portion of this paragraph, is that, remember back to that Ascii table where we had the decimal column, so you had decimal values representing the characters, or we also had the hexadecimal values representing the characters. So if we want to represent our characters in a decimal fashion, you want to put a D before the value. If you want to represent them in a hexadecimal, then you would put an X before the value. So here further down in this code, you can see that we're converting to a string whatever the character is that's encoded decimal 3. And then down here, we're converting to a string the value of whatever this particular byte is when we use the hexadecimal value of 2, which should be, in that particular case, just 2. And then further down, we're doing X is 4. So let's go ahead and copy all this code. Here's the results that we should be getting as our output. So you can see it's just actually showing us the string representation then of those values. So there's the decimal, there's the hexadecimal, and then there's the binary. So it just depends on what we type in as to, which, these always going to get those 3 types, because that's what the outputs are doing right here. So let's copy all that. Now this one is not a complete program at all. It basically declares and initializes an array that contains all those byte values. And then we just use a new structure here that you haven't seen yet. This is coming up a little later on when we look at repetition structures, but a for each loop. And in a for each loop, what we're doing is we're basically saying, go through this array byte and show us the number that's inside of that array one at a time, essentially. So for each element, so remember in an array, we have multiple values. So this would be at the 0 index, this is at the 1 index, this is at the 2 index, this is at the 3 index. So what a for each does is it just goes through that entire array and grabs each value one by one, and then allows us to, in the case here, output what those values represent in the different formats. But it's not a complete bit of code. So what that means is, in our new project, once we create it, this will all go inside of the main function, or the main method, I should say, in our code. So I'm going to copy everything down to, hold on, go ahead.
What's the advantage of using an array over a list?
Actually, a list is better because a list is much more flexible, but a list is not quite as efficient in memory. So an array is kind of the original way of storing multiple values to a single name. And it wasn't until later languages came along that they developed the list. In fact, Python doesn't even have an array. They just have a list.
Okay, thank you.
But list is usually more flexible. Usually you can put any data type in there and a list doesn't care. And as I mentioned earlier, with arrays, it does depend on the programming language, whether you can put different data types within a single array or not.
Okay, thank you.
So you can kind of think of a list as a more enhanced array. So I'm just going to copy the code and just pay attention to the code I'm copying here. So I'm starting from the word byte with the square brackets. So that's a little bit, you know, we saw this earlier. I didn't explain it. You're identifying the data type as being bytes. So each individual value going to be stored in this array will be a byte type. But in addition to that, we're using the square brackets here to tell the compiler our intention is to create an array here. So we're saying we want to create an array of bytes, and we're going to call it numbers. So that's the identifier, is the word numbers. The data type is a byte, but that's the type of each value that's going to be inside of this larger collection, which is called an array. So anytime you're referencing arrays, you'll see that's the code that we use, open bracket, square bracket. If you wanted to target a specific one within that array, then you actually call it by name. So you would actually use that identifier, numbers, and right after numbers, you'd have the square brackets, and you would actually put in the index number, like 0 or 1 or 2, and then that would retrieve that specific value from the numbers array at whatever index you were identifying within that array. Whereas the for each loop does essentially the same thing. It's starting at the beginning, it grabs the first value and then runs through the code, and then it loops back again, grabs the next value, loops through the code, then it runs, grabs the next value, loops through, and then the last value, and finishes that loop. And the way that this is terminated, again, we're using curly braces here. So this is the beginning of the for each loop. And right down here, that's the end of the for each loop. So that's when you're copying your code, you got to make sure you get that closing curly brace right there. So that's what I'm going to copy, Control C. Now I'll go back to my Visual Studio. I'm going to create another new project. Was there a recommendation on this one? I don't see anything there. So we'll just call it a byte type, or bytes. We can just call it bytes. So remember that when you're creating the new project, you always want to go to the Solution Explorer, go to the top of the list there in the Solution Explorer, which is your solution name. Right-click on the solution, choose Add, and then from the flyout, New Project, choose your type, Console, .NET Core, C#, click Next, and we'll just type in then bytes for the project name, and click Create. Once our project comes up in the Solution Explorer, so I don't forget, I'm going to immediately select it, right-click on it, and then choose the Set as Startup Project option. It changes to bold, so now I know when I get my code in here, it should run that project. So as I mentioned, the code that we just copied was not complete code. It was just code that needs to be put inside of the main method. So you can see that I'm highlighting, I'm back in the source code, the source code editor here on the left of the Solution Explorer. I've just selected line 9 in my case, which is that console write line. So we just want to replace that line of text with all the code that we just copied there from the lesson. So again, we're defining a new array of bytes that's called numbers. We've initialized it with 4 values, 0, 16, 104, and 213. And then we're just running a for each loop where it grabs each individual value then from the array. And then, let's see, it writes out this string text here. And in this example here, then, it's taking our first value, because you got to remember now, this is a loop, right? The for each is a loop. So it takes the first value, runs each of these statements, then the second value, each of these statements. So the same steps are being performed on all 4 numbers as we go through the loop each time. So right here, we got a string value. You can see that this is what gets printed to the screen. And then we take the actual value to the right here and display it in that right statement. The next line is going to display 3 digits with leading zeros. So that's when this one is set up. So we actually are getting a little bit of formatting. So right up here, we're just simply converting the whatever number, 0, 16, 104, 213, we're just converting them to the string value here. You know, what does it look like in chars, essentially? That's it. But down here now, you'll notice they also added this information inside of the toString method. And that's a formatting instruction, which is saying we want to have 3 digits displayed, or actually 3 decimal values displayed, so D for decimal. The next one down, you can see, is the X, so we want to see 2-digit hexadecimal value, and the last one is a 4-digit hexadecimal value. And then we're adding a space in between. We haven't got to concatenation quite yet, but that's what the plus operator is used here. So again, you were asking about mathematical symbols and whatnot. They do mean different things depending on the context of the programming language. So sometimes plus will be, you know, add this value to that value. In this case here, it is kind of add this value, but we call it concatenate. What we're saying is you want to print out this value here, and then right after it, also display this value. So you're not really adding it, you know, like numerically. We're not adding 3 plus 3 or 3 plus space in this case. What we're saying is that when you display the text as a string to the screen there, now add some spaces after it. So that's in both of these cases here. You see, we're just adding some additional spacing. So let's go ahead and run this. I'm going to save it, Control S. We're going to run it, Control F5. All the values are already in there. It's not taking any input. So really, it's just displaying the actual number from the array, and then to the right, showing the different formats. So without using the decimal format, or actually, no, the first one is the decimal format, 3 digits. Then you've got the hexadecimal 2 digits, and then you got the hexadecimal 4 digits. So again, remember, those are just the actual numeric values represented in different numbering systems. Okay, back to the lesson. Next one here, we're doing a byte of numbers. This one just adds octal in there. So it's the same as the other one. It's including octal. You don't really use octal all that much though. But you can see it's just the same basic output. Although we did add binary in here too. So this one now actually will give us the binary representation of these values as well. I'll go ahead and, you know, skip that one. You can go ahead and do that one on your own outside of class. Just add it as a new project. It is not a complete project. So just like the last example, you would just copy everything down to that closing curly and just paste it inside of the main method of your new project. So let's move on to the ints. Ints is something that we use quite often because a lot of times we have numeric values that we want to use in our programs. And remember that ints would represent numeric values that don't have decimal places. And again, you do have, you know, initially you have the int, which is all positive values, but you can also use another data type called a uint, which is your unsigned int values. So initially, actually, trying to determine this one here. Yeah, so initially, actually, int does give us, it is a signed data type because you can see it's only given us 2 million. And if you're using 32 bits, 2 to the 32nd power is like, or 2 billion, I should say. And int 32, 2 to the 32nd power is over 4 billion. In fact, that number is right down here. This is what 2 to the 32nd power is. So if you use an unsigned integer, meaning it doesn't have to have that negative symbol, meaning we can use all 32 bits to represent the number, then you're going to get the true representation of 2 to the 32nd power, 4,294,967,295. An int itself is a signed data type, and so you can go negative 2 billion or positive 2 billion. But again, just the main thing with an int is, you know, no decimal places. So here we just have examples, not any real code, just kind of some different examples there. Down a little bit further, you can see now we're doing decimal values. So decimal values are integers that have decimals. In this case, again, creating an array here of values. And so this one's showing what the minimum value of a decimal can be. And then we've got some other values here, all in decimal values all the way up to maximum. In this case, in the for each loop, we're even taking it a step further. This is like one of the last things we'll actually teach in this class, which is exception handling. So we talked about errors in a previous lesson that, compile errors mean that you haven't typed the code correctly. The syntax is wrong. But it's possible you've typed the syntax correctly, but you still have logic errors in your code. And so this is kind of demonstrating that example where we're going to end up dividing by a 0, I think it is in this case. And so we get the divide by any type of logic error that you have in your program. The program will load into memory for the user, but when they go to run it, because it's a logic error, and a good example is the divide by 0, that'll actually crash the program and it'll end. And so we don't want that to happen. So by using what we call a try-catch block, we can actually say, try this. If it fails, don't crash the program. Instead, handle it. And that's what the catch portion of that is doing. It's doing what we call the handling. In this case, it's identifying to the user what the actual error was that was occurring, but the program itself is not crashing. They don't have to go back and start the program over again. The program's still running, but it's identifying to the user what the error is. So it depends on the errors, whether they can actually continue in the program. But if you've written the code properly, that's the whole idea of a try-catch, is that you've identified there's a possibility this error could occur. If it happens, let's catch it and make it so the user can continue using our program regardless. That's coming at the end, so don't worry about that too much. Okay, so this one here will actually give us some output. You can see we're creating some integers in an array. Again, we're calling it numbers. Here's the different values. And again, we're using the toString method and some formatting here to get different types of output from it. So let's go ahead and grab this one and put it into a project. And we want to go all the way down to the curly brace because that's the ending of that for each loop. So I'll copy that code. We'll go back now into our project and create a new project in this solution. So I'm right-clicking on the solution in the Solution Explorer, choosing Add, and then new project, console app C#. This one here, I'll just call it int variables. Create it. Let's instantly come over here and make it the set it as our startup project. And then inside of main, again, that's all I want to do is just select that one line of code, the console write line hello world, because the code we've copied needs to be placed inside of main. So once I select it, I can do my Control V, placed it in there. And now we go ahead and run it, Control F5. And there you can see the output again in all the different formats there. So you can see we had the negative value with no formatting initially. So if you look at the toString, you can see that that's all we did was just convert number to string there. Then in the next value, they actually put it in the format that has the comma and decimal to represent the decimal places. So that's this one here. Then the next one is showing the hexadecimal values. In the without leading zeros. And then the last one is showing the hexadecimal values with leading zeros. So you notice that the first value, right, is the same in both of those columns because there's no leading zeros in that value. But down here, these next ones, they all began with leading zeros. And so this one, this format here just removes all of those leading zeros. Which would be this format. No, that's this one here gives you the leading zeros. This one here, you can see the X is the hexadecimal, and then 2, meaning you're only going to get 2 places, no zeros, no leading zeros. So not anything really new in there. I think that's pretty well been covered as far as those steps that we did there. So let me just close that up, come back to here. Now we look at floats. So again, floats like decimal are numeric values that can contain decimal places. And so again, we have a lot of different formats and whatnot that we can use. Doubles, same thing, numbers that can have decimal places. Every once in a while, you may get an error. You know, these sample codes that I've given you have been checked out. We've run them before. We know that they work. But if you type in new code and you're doing some sort of mathematical operations or numeric assignments and you don't get it quite right, it's possible you may see this as a result, NaN. And so that stands for not a number. So that means that you attempted to display a numeric value or perform math on a numeric value, but the variable itself wasn't in the format. You know, wasn't a data type of a numeric value that could be manipulated mathematically. And so just be aware of that, not a number. That's a common thing to see when we make errors where we try to maybe use a string in a math statement or something along those lines. And also this demonstrates, now that we're down here in the char portion, a new concept that's quite common in all programming languages, which is using the / character as what we call an escape character, or it begins an escape sequence, you can say as well. So the idea of an escape character, which is the / character, is that if we put that in before another character, that's basically telling the compiler, don't use that character as its literal value, use it as some sort of a coding value. And so in this case here, we're having to / out the fact that we're putting that we're telling the compiler or the interpreter that we want this value to be represented in hexadecimal. So anytime that we put the X in front of a number, that tells the compiler or the interpreter that the value is a hexadecimal value. But it would treat it like the letter X if we didn't put the / character in front of it. So that says, don't treat this like the letter X, treat this like a designation that this value to the right of it is hexadecimal. And then down here, we're doing Unicode. So /U, and then the value in Unicode for that character. So that's called an escape sequence. The / character is the escape code, so to speak. So that's one way of modifying the values. And then earlier I showed you the concept of casting, which is we can, in parentheses, put down the data type that we want to convert it to. Let's go ahead and put some of this code in here. This got some interesting examples of the char. So the first one is creating a char called character. And then notice here that char, when we want to assign a value that is a char value to a variable name, we have to use single quotes to represent that that's a char data type, as opposed to the double quotes, which represents that it's a string data type. We do have a video, it's the next video I believe that's coming up here, that actually identifies the fact that there are times when you need to output string text, and in that string text, you may need to have an apostrophe. You know, maybe you have that's, like, you know, THAT''S. So how do we handle that? And so that's coming up in the video there. You'll see that you just basically, you alternate between the quoting types. But anytime you're assigning a char value to a variable, the char value needs to be in single quotes. So that's what the first one, just going to display that character. The next one, you can see that we're using the Unicode value for the character. And let's see, the next one is, okay, so here's an example of needing to have an actual single quote displayed. So notice that it's going to be a char, because that's what our data type we've already defined up here. Character is of type char. So down here, when we go to assign this text into it, it's in single quotes to indicate it's a char, but what we're trying to display is an actual single quote. So you'll notice the sequence, right? We have on the beginning and the end of this, those two single quotes to say everything in between is a char. But then we got that escape character, the /. It says, don't treat the very next character as just a single quote. you want to actually display it as a single quote. And so when we come down to the results here, you'll see that's exactly what we'll get, just the single quote. You may also need to escape a backslash character, meaning you need to display a backslash character. Well, normally the interpreters or the compiler, either one, are going to interpret that as a backslash. Oops, this character here, going to interpret that as a backslash. In other words, oh, you want me to escape this character. So it would think, oh, you want to display a quote again. But in this case, no. The first character backslash, it's our escape character. And what it's telling the compiler or interpreter is this character needs to be actually displayed to the screen. So don't treat that as the backslash character now like you normally would. Now just display it as the backslash character. So the literal value essentially. So let's go ahead and just put all of this inside of a main method. Copy from there. Just trying to get all the spacing here. So there we go, all the way down to there. Copy that. When I go back to Visual Studio, I want to create a new project. And we're going to call this one Char. So add new project, C# console.NET Core. We'll just call it Char. Char variable. Create it, and then right inside of our main, just replace everything I copied there. So now it should go through, establish our char character, assign an actual char, again, that's inside of single quotes there, to the name character, then write out the output. Then you see here now, we're not declaring it anymore, we're just changing the value of it as we go through. So in here now, it's just using the Unicode value and then outputting what character is at that point. Here, using the escape character, so it'll display the single quote, so that'll be output. And then here, want to display the backslash, so that'll be output there. So let's save that. We need to go back in our Solution Explorer. I forgot to set this as my startup project, so we'll do that. Now I'll run it, Control F5. And there you can see the output. So we get the letter A, we get a colon, we get a single quote, and we get a backslash. In the example, this would be a good way to actually show you this too. In our source code example that I had in the lesson, they were all on one line. And so here's a good example of using WriteLine. How what WriteLine does is, put each character on a separate line. So let me run it again just to so you can see that, right? So each output, each console write line is on a different line. So I'm just going to remove, just so you can see this now, the word line from there. This should give us then output that's all on the same line. The only thing is I haven't put any real spacing in here, so it'll probably all be bunched together. Get rid of that one too. There we go. So I'll save that and I'll go back now and run it, Control F5. So now you can see there's the output, A, colon, the single quote, backslash, all on one line. So just emphasizing again the difference between that method write and WriteLine. So we're moving up to strings now. So we've covered kind of the basic value types. So now we move on to one of our reference types, which is strings. And again, just remember the string is a collection of chars inside of an array. And so the address really of the string is being stored on the stack, and that address then points to the memory location where the first character of the string begins. So I got a little video here that kind of shows you some features about using strings, because it's one of the most common variable types or data types that we do use in our coding programs. All right, so let's fire off this video and see if that's right.
When we want to deal with text in our programs, characters, words, sentences, email addresses, well, we use the term strings to describe those kind of values.
Yeah.
Now, we've seen these already. Anytime you see words contained in sets of quotes, we're dealing with strings. The first line of code that we wrote was this alert message that used the string hello world. This value contained in the double quotes is referred to as a string literal, just like the number 5 or the number 1,000,000 would be a numeric literal. We can, of course, use this format to create variables. I could create a new variable called message and set it equal to the words hello world. I could then use that variable and pop out another alert box. So we're using the string literal to create the variable called message and then writing that variable out. Now notice that I'm not using double quotes around message in this second alert statement because I don't want to write out the word message. I want to write out the value of the variable called message. Now when we're creating strings, you can use double quotes to surround the text or the sentence. You can also use single quotes. What you can't do is mix the two. You can't, for example, open with a single quote and close with a double quote. Most other programming languages restrict you to just double quotes, so I tend to use that in JavaScript too, just to make it easier to go from language to language. One of the reasons you might change between the two formats is if you need to have quotes inside quotes. Let me show you what I mean. Let's say, for example, we want the phrase, "don't mix your quotes," contained inside a string. Well, if we used single quotes to mark out the start and the end of this string, we're going to have a problem, because there's also a single quote in the middle of it, and that's how we're telling JavaScript where the string begins and where it ends. So what I could do here is use double quotes with a single quote contained inside them. That would be perfectly fine. However, that gets a little tougher when we have a more complex sentence. Let's say, for example, we want a phrase that contains both double quotes and single quotes. Well, there's no simple way to mark out the beginning and the end of this without doing something else here. If this is what we need, what we can do is what's called escaping the quotes. This would be the way that I'd have to write it. The entire string begins and ends with double quotes. And that means if I want double quotes inside that string, I mark them by putting a backslash before the double quotes being used inside the body of the string itself. Now, one of the great benefits of dealing with strings in most programming languages is they're smart. These variables go beyond just having a holding place for some characters. We can ask things of them. We'll get into this a lot later, but just to give you a basic example. Let's say I create a new variable called phrase and set it to the words, "This is a simple phrase." One of the things I can do is I can use the name of that variable to access or get to information about it, such as how long is it? I can also ask questions of it, like does another word exist inside it? I can convert it to upper or lower case. As the most straightforward example here, I'm going to write the line alert, and then instead of just the name phrase, I'm going to say phrase.length. This is allowing me to get to what is called the length property of this variable. And what's going to happen is this will pop up an alert box that will say, in this case, 24. We can actually ask questions of our string variables. And as we get deeper into creating and working with any language, you'll find this is very common, that variables by themselves aren't dumb. They can actually give us more information about the contents and about what they're holding. Now, we'll get deeper into strings a little later on, but that's enough to get us started.
So in that video, you learned about the length property. And so the length property, as he said, will give us the actual number of characters. You know, again, that's a very nice feature that we have in modern day programming, is the fact that most all of these what we call intrinsic data types are actually in the background built as objects. And so they have all these really nice methods and properties that we can use to manipulate all of our values with. And so length is one that we use quite common to be able to check out, obviously, you know, how many characters are in a string. So in this first example here, we're going to take you kind of a little bit further down the road now and start getting you ready for what's coming up in your next assignment. So in this example, you can see that we're just simply declaring three variables, X, Y, and Z, all of string type. We are going to, what the goal is here is just take input then from the user and assign their input to each one of those string variables. So you can see that we're giving them instruction here to enter a value for our X. So once they type something in, the read line statement here will take that value and then assign it to that X variable. Same thing with the Y. Here's just a prompt asking them to enter a value for Y. So the read line then takes that value typed in, assigns it to Y. And the same thing with Z, prompt here to enter the value, and then this code here to actually assign the incoming value from the keyboard to Z. Then down here, we output it actually using a newer format. And yeah, I did have the other format down here, so I can compare it for you. The reason this is the newer format is we're using this special character before the string, the output that we're generating. And that's called the string interpolation operator. What that is telling the compiler is to go ahead and read the values of each variable. So that's being represented right here in the curly braces. So the way that this reads, inside of the quote, we're saying to the write line method, you want to write the letter X followed by an equal symbol, but then you want to go and get the actual value in this case, it's a string value. So in this case in the heap, grab the actual value of X and then display it right there. Follow that by a comma and then a space, and then display the Y character followed by the equal symbol, and then now go back to the heap, grab the value of Y, display it right there, followed by a comma, space, and then show the letter Z and show the equal symbol, and now go get the value of Z out of memory and display that value right there. Compare that to the way that I did it here initially. This is the old way of doing things. And I want you to learn the new way and use the new way. The old way was that we used what were called placeholders. See, here in this last line on line 18 in the graphic, I'm not actually asking the compiler interpreter to go get the value. I'm actually saying this is the first variable I have listed over here on the right that I want you to display its value. So what we had to do is we created the whole string input here on line 18 between quotes, followed by a comma, and then we had to list the variables that were then going to be used for the display in the string. So X is since it's the first variable listed here in the list, that would be the 0 value or the 0 variable. It's kind of like an array. That's kind of what we put out here. We said, here's an array of 3 different strings that we want to display the values from. So the first one's identified as 0 because it's first in the list. The second one then is the number 1 item in that list. And then the third one is the number 2 item. So they're those placeholders, the curly braces with the numeric values inside of them are referring to the actual variables listed to the right. So that is not as readable a code, if you think about it, when you compare it to what we have up here. Here now, we're able to, because we're using that string interpolation operator, the $, we're actually able to, in the curly braces, identify by name the actual variable that we want to retrieve the value from. So it's much better coding, right? It's easier to see what the heck's going on there. And students have always had a problem with this other method here too. So I'm glad that they have provided us with that capability now. All right, now we get into the operators. So we were talking about the data types. So now we need to be able to manipulate these data types. And so there's all these different operators that we can use then for that manipulation. So we'll go ahead and jump into this video here, and then we'll come back and continue on with the operators.
So we've seen that JavaScript has words like alert and prompt. They're causing it to do things, to pop up dialog boxes. But also it's beginning to be obvious that there are symbols, like the equal sign, that are absolutely as meaningful as words are in a programming language. Because this also causes things to happen. It can take the literal value 500 and cause it to be put in the variable called balance. And this equal sign, this assignment operator, is one of many operators in programming languages that will cause things to happen. Let's explore a few more of these operators by starting off with a few that you already know how to use. So the most obvious ones are the arithmetic operators. We have operators for addition, subtraction, multiplication, and division, which we're using the asterisk for multiplication and the / for division. And we're usually using this in combination with the equal sign as well. But let's say we create a couple of variables, variable A equal to 100, variable B, set it equal to 50. And then we can use the plus sign on the right-hand side of the assignment operator to perform this operation, to add these two together and save the result in a new variable called result. In this case, this would be 150. Or we could change that plus sign for a minus sign and do subtraction. And I think you know where I'm going with the asterisk for multiplication or the / for division. But what we're doing is evaluating what's on the right-hand side of the equal sign and assigning that value to what's on the left-hand side of the equal sign. Now you can use multiple operators together, but JavaScript, like any programming language, does have operator precedence, simply meaning some of these operator symbols are treated as more important than others. So let's say with this simple statement, if you just read this left to right, you're going to see what's on the right-hand side of the equal sign, and you're going to say 5 plus 5 is 10, times 10 is 100. But no, the multiplication is regarded as more important. So the 5 multiplied by 10 is done first, which is 50, and then we add 5 to it, and the result would be 55. If I want to make sure that I can impose an order on this and I have multiple operators, I simply take the important pieces and I surround them with parentheses. So in this one, for example, I can make sure that 5 plus 5 will be evaluated by itself as 10, and then multiplied by 10, and we have 100. Now, one thing that's very common is to see the same variable name on both sides of the equal sign. But remember, what we're looking at is to evaluate whatever's on the right-hand side. We take that as an expression. So the first thing we do here is we look at whatever the current value of score is, and then we'll add 10 to it. And then we'll store the result in the variable score. So if its score is 100, it'll now be 110. This idea to add a value to an existing variable rather than creating a new variable is so common that there is a shorthand for it, which is plus equals. Score plus equals 10 just simply means take whatever the value of the score variable is and add 10 to it. Now here, the plus and the equal sign have to be written as 1. There's no space in between them. This is considered one operator. And the same way there is a plus equals, we also have minus equals, an asterisk equals, and a / equals for subtract a value or multiply a value or divide a value. Not only that, but it's very common to see something like this. If we want to just add 1 to an existing variable, well, we could write it out, such as a equals a plus 1, or we have that shorthand a plus equals 1. But the idea of an increment, of just adding 1 to a variable, is so common, it actually has its own shorthand, which is plus plus. A plus plus simply means add 1 to the variable a. This idea is where the language C++ got its name from. It's the idea of C plus 1, the next version of C. And the same idea, we can subtract 1 from a variable by writing it longhand, a equals a minus 1, or saying a minus equals 1, or just a minus minus. The plus plus is called the increment operator, the minus minus is called the decrement operator. So as you can see, these symbols have as much of an importance within a programming language as the words themselves do. And we have a few more that we'll explore as the course goes on, but this will be enough to get us started. Java.
So you can see as we evolved in programming languages, programmers got lazier and lazier, right? We had to have simpler ways of just incrementing numeric values in our variables. So I've actually organized this section. There's a lot of ways of organizing your operators. And so this section here, we're going to go through and look at them based on the fact, are they unary operators, binary operators, or ternary operators? So let me explain it to you. Unary means that there's only one operand involved. So remember now, the operator is the symbol that performs the mathematical operation. The operand is the value that we're performing that mathematical operation on. So in the example we're looking at here, X is the operand and the plus plus is the operator. So since there's only one operand, obviously then that's a unary, meaning it operates on a single operand. Next, we look at the concept of binary operators. So that means now we have 2 operands. So a plus symbol, you can see we have an operand on the left of it and an operand on the right of it. It uses 2 operands. Same with the greater than symbol. It uses two operands, one on the left, one on the right. And then we have this ternary operator, which really is kind of a shorthand for if statements. The idea of an if statement, remember, is to evaluate whether a particular expression is true or false and then act accordingly. So the format is we write out our condition first, and then usually we put it in a set of parentheses. So is, X greater than Y. That would be an example of the actual expression. We follow that then by the question mark symbol, so that follows the condition. And then you have two values, essentially, that'll always follow the condition. What if the condition is true? There's the value you want to display. Or if that expression is false, then this is the value that gets displayed. So the compiler interpreter just comes in, looks at that condition. Let's say we'll use that example of X greater than Y. So if X is greater than Y, whatever was typed in here will be the output of that result. So we could actually, to the left of all of this, this would be to the left of the assignment operator. You could actually have something like Z equals, and then that whole statement there, and then Z's value will be determined whether or not the condition here is true or false. So you could have the output be true or false, or you could come up with something totally different. Maybe you want to do a console.writeLine statement for true or false. You could put those in there as well. You could actually be pretty complex in the output side of things here to the right of the question mark. So just shorthand for an if statement. In fact, this here, this is just going through the operators by function. So this is based on number of operands. This grouping is based on the functionality. So is it an arithmetic operator, is it a conditional operator, or is it a logical operator? So you can see there's just several ways that we can actually organize all these operators into different categories, either by the number of operands that they operate on, or by their, what they call the function, whether they're arithmetic functions, conditional functions, or logical functions. So then we have a table that lists them. You can see this table, by the way, is listing the order or the precedence. So in the video there, the narrator talked about order or precedence, meaning that certain mathematical operations always occur before other. So multiplication, for instance, always before addition was what he was showing you in the example there. The reality is those increment and decrement postfix operators. Now, he didn't get too much into postfix and prefix when he was talking about these particular operators, the plus plus and the minus minus. So you need to know that postfix means that it comes after the variable name, and prefix, like down here, those come before the variable name. So a postfix operation occurs before a prefix operation. And I got an example of that down below here, so it'll help sort that out for you. As far as multiplicative, that's the category. You've got your multiplication symbol is the asterisk. You've got your / is your division, and then you've got your % symbol for the modulus. Remember, that gives you the remainder of a division problem. For addition, subtraction, you got plus and minus. Shifting, you won't have to deal with that. You get down to lower level working on computers, you start dealing at the bit level, and you may need to shift the bits, and you use those characters for that purpose. Relational testing, so this is conditional operations. These are the characters that we use to see if the value on the left is less than the value on the right. So that'd be the less than operator. This is the greater than operator. So now we're checking to see if the value on the left is greater than the value on the right. And then this is just an extension of the lesser one, right? This is saying, is it lesser than or equal to? Whereas this one here is it equal to, greater than or equal to? And then we have is, so is a data type, or as, where you're essentially casting the data type at that point. You won't have to worry about that one in this class. Next one down is equality. And so you really need to make a note to yourself on this one. This is the most common mistake for beginning programmers, wanting to use the equal symbol as a check to see if a value on the left is equal to the value on the right. So in other words, you will never want to write x equals y and think that that's going to be a proper expression where x is going to be evaluated to see if it is equal to y. That doesn't happen. Equals is the assignment operator, period. When we use multiple equal signs, that's how we do comparisons. So the first one, the double equal sign here, is what I would use if I want to test to see if the value of x does compare to, is the better way of reading this. So is x compared to the value stored in y? So I'd have x to the left of that symbol, the two equal signs, and then I'd have y to the right of it to read that way. Is x compared to y? If I do the exclamation point before the equal symbol, that's does not compare to. So remember, the first one is compare to, the second one is not compare to, and then the remaining two are just a little bit more intense. Three equal symbols is compare to as far as value and type, meaning are they both of the same value and are they both of the same data type? Because it's possible you may have an int that's the number 3 and you may have a string that's the number 3. Well, if I use a strict comparison on it, that will return false because they are not equal both in value and in type. If I just simply use the first comparison operator here, that would return true regardless of the data type. So if I had an integer, or an integer was 3 and a double is 3 and a string is 3, they'd all compare to each other. That would return true. But when I do strict comparison, I'm looking at both the value and the type. And so then this is just the negative of that. You put the exclamation point in front of two equal symbols, and so that is the strict does not compare to. So then we get into the logical operators. When we start creating these if expressions, you may need to compare more than one thing. So you may want to say, is x greater than y and z less than 0? You know, those two conditions both have to be met before the statement expresses or evaluates to true. We could use or. So in the case of an and, both of those expressions would have to be true for the whole expression to evaluate to true. If we use or, any part of the expression, if it resolves to true, then the entire expression resolves to true. In fact, that's right. The first one there, the caret, which is the up-facing kind of arrow, that's, what is that on the keyboard?
It's logic X or.
No. I'm just saying on your keyboard, if you do shift and the number key 6, that's that symbol that we call that a caret, the up-facing arrow there.
Forgot. Exponent. Caret?
No. Oh, I see what you're saying. No, yeah, that has been used as an exponent representation as well. Yes. But in this case, it would not be for exponents. It's just simply using the logical not or. That's what the X in front of the or is not or.
Oh, okay.
Okay. The more commonly used or in your expressions will be the one below it, which that's actually called the piping symbol. This goes back to the days of DOS. You'll find that's the character that's right above your enter key. You have the backslash as the lowercase character, but if you hold down the shift and you press the backslash, you get that vertical bar, which is called the piping symbol. In this case, in programming, we use it as an or. And all of those are for when we're doing logic. So in a logic statement, it's not quite the same as what I was explaining earlier, the expressions that we create inside like an if parentheses. Those are all going to be the conditional operators. So the logicals are actually more when you're testing values individually. The conditionals are more when you're going to have, you know, these long expressions one after the other. Well, they don't have to be long, but more than one expression, I guess just to say, within inside of the parentheses. And so it still works the same. You're saying if the expression on the left and the expression on the right are true, then the whole expression is true. or means that either of the expressions has to be true for it to evaluate the true. And then the last one, the conditional operator, we told you that's just shorthand for if. You put the condition to the left of the question mark. That's followed by, to the right of the question mark, two results. The first result always being the true result, separated by the false result with a colon. So it's condition first, question mark, true value, colon, false value. And that pattern was up above there for you. If you want to go back and review it.
I have a question.
Yes, go ahead.
Is there such thing as a non-and? Like
Oh, yeah.
not and?
Not and.
Just like the
No.
caret one.
Yeah, no, there's not going to be a not and. You just, my thinking would be, what I think what you're really getting at is probably more the comparison. So what you could have is, x not equal to y, and y does compare to z. So you're saying two conditions. See, you can't, because a not condition would mean just don't put the condition in there. So there's really no need for it.
Oh,
See what I'm saying? Then the last one there is your assignment operators. That was pretty well demonstrated, I think, in the video for you. Just whatever the value is on the right of the equal sign is going to be assigned to the variable listed on the left of the equal sign. So you have it equal to a value or times equal. So this is when you've already got a value assigned to x. X is 2, and you want to increment it by 3. So you could do x times equals 2, or 3, I should say. You also have divide equals and modulus equals. So the whole idea is it takes the current value of that variable and then performs the mathematical operation and then updates the variable with the results. So you got modulus equals, plus equals, minus equals, lesser than equals, greater than equals, caret equals, which would be in a logical not or the or equals. So that's all in the logical. This will be much clearer if it's still a little fuzzy to you. Once we actually start writing out the expressions, you'll be able to see it much clearer. The next portion of this gets down to the incrementing I was telling you about earlier, how the post increment takes precedence over the pre-increment, and that's true for decrement as well. So this is the example I'm looking at right here. So the idea is, in this case, how we're demonstrating it is we just create an integer variable x, assign a value of 10 to it. When we apply the x post increment operator, that will increase the value of x by 1. And so that's what we see right here. That's the value of x. That is actually then changing the value of x before it's assigning it. So you got to realize that this is just 3 statements in a row here. So we created the variable x, gave it a value of 10, and then right here we post incremented it. And if we were to look at it, if we were to do like a console write line and look at x at that point in time, we would see that it's now actually the value of 11. With the pre-increment operator, you can see that it's taking the current value of x, which is 11, and actually assigning it now as 12. And actually, now I think about it, that's not, actually this is the one that's correct here. I'm not sure where that one came from. So Unary adds 1. Oh, this is just showing you that it adds 1 regardless of whether it's post or pre. This is the one I really wanted to show you because this is actually demonstrating how the pre-operator will actually assign the value to x before it well, let's pretend these are in console.write statements. So before they're actually processed is what I wanted to say there. So let's go back at it again here. So we've got integer x is initially 10. When we post increment, so let's say this is console.write line x plus plus. Post increment occurs after the console.write line statement runs. So in this case, it's still going to show the previous value of x. Whereas the pre-increment operator actually does modify the value of x before the output is generated. So what's happening is, just if you, again, these are 3 consecutive statements being processed in a program. We first get the value of 10 for x, then we assign a value, in this case, to y. We're just not doing a console output. But the value on the right here was not incremented before it got assigned to y. So y is still the same value as the original value here. Whereas on the pre-increment, it does increment the variable before it does the output. So at this point, again, you have to follow the logic that, you know, and know this is one single program running at the same time. We run that line, we get 10 at x. At this line, y becomes 10, but the post increment does run after the assignment. So actually, in memory, x is now equal to 11. And then down here, where we go to assign the current value of x to z, we're using the pre-increment, which immediately increments the x from 11 to 12, and then assigns it to the variable z. So pre-increment is going to assign, you know, after the calculation. Post-increment assigns before the actual calculation. We usually use post-increments, you'll see, when we start doing these for loops, because you'll say each time through the loop, we want to increment our variable by 1. We usually have a counter variable, and we want to increment it by 1 each time we go through the loop. So that's where we most commonly see the post-increment operator being used. Or minus if you're counting down as opposed to counting up in a loop. Yeah, so here I have that actual example for you. In fact, this is a full program. Let's go ahead and put that into our solution that we have there. So let's copy that. Let's get back to our Visual Studio. Let's create a new project in here. So add new project. Going to be a C# console.NET Core. Let's just call this post and pre-increment. Create it, and then everything in here gets replaced because that was a full program. Save that, and let's come over here now, make this our default program, our startup project, and then we'll run it. So this will show us exactly what I was just telling you there. You can see that when we took the initial value of x, that's this one right here. So this line right here runs. Then we attempt to post increment y, and then we output the values of x and y. So that's what you're seeing in that first line, right? So x is 11 at that point, but the value of y, because the post increment is after the assignment operator, occurs after the assignment, y shows us the value of 10. Then on the next one, we assign, using the pre-increment operator, the value of x. So since the operator is running, you know, previously x was 11 and the line before it, now it's incrementing again. So now the value is 12, and that occurs before the assignment operator is active. And so that's why z, when it gets assigned its value, it is indeed 12. So it's, you know, something you certainly need to be aware of from a programmer standpoint to understand those differences. Because if you're off by 1, you're going to get some bugs in your program. So important to understand all that. Got a couple more videos here. Assignment comparison and usage of the logical operators, and then addition versus concatenation. And then just a couple more topics after that that we need to cover as well today.
So when we're writing if statements and we want to check that one variable is equal to another variable, we use the double equal sign, the equality operator. In this case, if the contents of the variable A are equal to the contents of the variable B, we're going to execute whatever statements are inside the opening and closing curly braces. But there's a mistake that's very easy to make. In fact, pretty much every programmer in a C-based language will make this at some time in their career, and that's to accidentally use assignment, the single equal sign, instead of equality, the double equal sign, or in JavaScript, the triple equal sign. What that means is that, say we create a couple of variables. Variable A, set it equal to 5. Variable B, set it equal to 10, using the single equal sign to assign, to set the values of these variables. A little later on in the code, I might write an if statement, and I'm asking, is A equal to B? But I accidentally used the single equal sign instead of the double equal sign. Well, we have a problem now. What's going to happen is we're going to execute the if statement, it's going to hit that code, and it will say, okay, single equal sign, that's assignment, and it will set A equal to the value B. And this successful operation will then be regarded as true, and the code inside the if statement block will always be executed, even when you think it shouldn't be. So we have just made A equal to B. Now, this is perfectly legal syntax in JavaScript, but it can lead to code that just doesn't work the way you expect, and it's difficult to debug because it's easy to miss. What we should have done here is use the double equal sign. So remember, when you see the single equal sign, that is the assignment operator. You are telling, this is a command. When you see the double equal sign, this is the equality operator. You're asking, is one thing equal to another thing? Now, and in JavaScript, and in a couple of other languages like PHP, there is another equality operator, which is the 3 equal sign or triple equal sign. Now, even if you're an experienced programmer, you might not have come across this one before. Again, it's in JavaScript, it's in PHP, but it's not in most C-based languages. A 3 equal sign is what's called the strict equality operator. Now, what the devil does this mean? Well, let me show you an example. So in this simple code here, I'm creating a variable called A, and I'm setting it to the number 123. Then I'm creating a variable called B, and I'm setting it to the string 123. Now remember that we talked about JavaScript being a weak typed language, that any variable can hold any kind of value, whether it's a number or a string or a Boolean. So what's happening here is I'm asking, is A equal to B? A is 123, B is 123, but it's a string. They're actually different types of data. Let me run this example. I'm going to run the HTML code that contains this, and it pops up the message, yes, they are equal. And that's what happens if I use the double equal sign. Even though, strictly speaking, they're different kinds of data, JavaScript is being flexible here. It's kind of saying, yeah, I know what you mean when you want to compare the two. You probably want to say this is true. However, if I used the triple equal sign here, and I'm just going to save that JavaScript, go back and reload the page, this would say, no, they're not equal. And this is the strict equality operator, the triple equals, which is going to make sure that not only do we have the values the same, but the types better be the same too. So variable A and variable B better both be numbers. One can't be a string. To make this equality check work, I'd have to remove the quotes here. If I then save that and refresh it again, it would say, yes, they are equal. They're equal. They're identical. They're both 123, and they're both numbers. When you're using JavaScript, some writers recommend using the triple equal sign all the time and never using double equals. I wouldn't go that far. When I see a double equal sign in some JavaScript, I don't think it's wrong, but it's certainly not a bad habit to get into, that when you're checking equality in JavaScript, you'd use the triple equal sign. So to round those up, we have if A is equal to B, using the double equal sign, or not equal to, using the exclamation mark equal sign. We have the strict equality, not just equal but identical. Similarly, we have the not strictly equal, the exclamation mark equals equals. All of this you're going to run into a lot. But we also have the other kinds of comparison. If A is greater than B. And again, remember, it doesn't really care what any of these values are. Whatever's in the parentheses just needs to be true or false. A is either greater than B or it is not. A is either less than B or it is not. We also have the greater than or equal to, and not surprisingly, the less than or equal to. All of these operators, if there's more than one character in them, you can't put a space in between them. They're all considered one indivisible unit. What we often then have to do is take it a step further. We need to ask multiple things at the same time. So let's say I've got 4 variables. And what I want to ask is if the variable A is equal to the variable B and the variable C is equal to the variable D. Now I could do this with 2 if statements, but it's nice to combine them all on one condition. I can't use the word and here. There are some languages where you do, things like the BASIC-based languages, but not in the C-based languages. What we use instead is the double ampersand. Now what this means is both of these conditions, A has to be equal to B, or strictly equal to B, and C has to be strictly equal to D for this whole thing to be regarded as true. Again, the entire contents of the parentheses have to be true. And sometimes we don't want to go that far. We might ask if A is strictly equal to B or C is strictly equal to D, then we want that condition to be true. Well, instead of the 2 ampersands, we use the 2 vertical bars, or pipe symbols, depending on what you call them, or how we say an or inside this condition. To make it a bit clearer to read, you often enclose the separate conditions inside their own set of parentheses. You don't have to do this, but it can make it a bit more readable. So in this case, we're saying if A is greater than B and C is less than D. And sometimes when you have these complex conditions with longer named variables, they can get pretty long, so you can break them onto multiple lines, although keep each unit together. I wouldn't typically take it this far, but because line breaks are insignificant, we could do it if we thought it made it more readable. So JavaScript is a weakly typed language, meaning our variables can hold numbers, they can hold strings, they can hold Booleans. But JavaScript still cares. It knows the difference and it treats those values differently. Let me show you an example. If I create 2 variables, foo and bar, and I give them numeric values, the number 5 without double quotes, then I call alert, adding them together. I'm using the addition operator, the plus sign. What I'll get will be the number 10. It understands these are numbers, it adds them together. If, on the other hand, I create these variables with the digit 5, but inside double quotes as a string, and then I use exactly the same code, I'm using the addition operator to add them together. What's going to happen is concatenation, not addition. They're going to put them beside each other, and what will be output is 5, 5. This is a behavior you do occasionally want to have happen even when the values in your strings are what we think of as numeric. Say you're working with area codes and phone numbers. You don't want to be in a situation where those will get added to each other and actually have a different number. You want them concatenated, one beside the other. Now, it might get a little more puzzling about what happens if you've got one of each. So what happens if one variable is a number and the other variable is a string? Well, what's going to happen is if one's a string, that's going to take charge. You'll get concatenation will occur. And where it can get even a bit more involved is what happens if you try and do something that just doesn't make sense. We create a variable foo equal to 5. We create variable bar equal to the letter B. And then we try and alert foo times bar, foo multiplied by bar. Well, concatenation doesn't work here. What you're actually going to get is this. You're going to get the value uppercase N, lowercase a, uppercase N. This is not a number. It's how JavaScript will represent something that just doesn't make sense. And JavaScript has this built-in idea of something being not a number. It's something that it understands, and this can come in very useful for us because sometimes we have variables that we want to be a number but aren't. Let's say, for example, we've got a variable equal to the string 55. So it could be numeric, but it could be ABC. It could be an exclamation mark. Perhaps we're asking somebody to type in a value into a prompt box. We hope it's a number, but it might not be. Well, what I can do first is I can create a new variable. We'll call it my number. I'm going to try and convert whatever's in foo into a number. Sometimes that'll work, sometimes it won't. It's a value like 55, it would work. If it was an exclamation mark, it wouldn't. Now this looks a little odd. This is a built-in function in JavaScript called number. And it's one of the few times we've seen an uppercase N here. We're passing in the variable foo and we're saying make it a number and store the result in the my number variable. Hopefully this will work. but it might not. So the next thing that I need to do is check it. And we use another built-in JavaScript function called isNotANumber, or isNaN. So isNaN is a built-in function in JavaScript. It accepts a variable, and it will tell us, is this a number or is it not a number? Now think about what it's called. isNaN, is not a number. What that means is we'll get true or false back from this. It will return true if this is not a number. And because this is in an if statement here, that's what we're asking. If it's not a number, we're going to pop up an alert message. Now, quite a lot of the time, what you want to actually ask is if something is a number. Well, there is no isNumber function. They can only tell us if it's not a number. So if I'm asking if something is a number, I'm actually going to do a weird double negative here. I'm going to use the exclamation mark to negate the call to the function. What I'm asking is if it's not a number, meaning is it a number? In which case, we'll then pop up the alert box saying, yes, it's a number. Looks a little strange, feels a little strange if it's the first time you've seen anything like this, but you'll find JavaScript has a few of these little things tucked away.
So realize that feature is only in JavaScript. and C#. They use not a number as a kind of just a way of representing values that aren't numbers. It's more a constant, really, than it is a function like they were showing in that particular video. So it does depend on the language. So, but NaN, like I mentioned to you earlier, is always going to represent not a number in your language, but it just depends on whether that language has the additional functionality to test for not a number, which they all do. But I guess my point would be that the method names are going to be different in different languages. The one he was showing you just strictly for JavaScript. Moving on, we're running out of time here. Only got about 8 minutes. So I would recommend that you watch this video here about regular expressions on your own. We don't do any regular expressions in this class, but you certainly will encounter them in your later coding courses that you take, especially I know for sure in the web development, we demonstrate using regular expressions to test out user input. So I'd like to check to make sure that they're typing in an email address, for instance. So just real quick, what a regular expression is a way of creating or identifying patterns that you want to have matched within some code or some input from a user. And like I say, my experience generally is that we use that for testing to see if the value typed in an input from a user is valid or not. So that's a good video, just kind of illustrates the basic concepts of regular expressions, just so you're familiar with it. Then the very last subject here is the special characters. I had introduced you earlier to the $ symbol, which is the string interpolation operator. And remember, all that does is change it so that we no longer have to put those placeholders when we're doing output. We no longer have to have placeholders of 0, 1, you know, however many variables are in our output. We can just put the actual variable name right in there. The key to it is, let me show you the example down here. So this is actually showing the two methods down here. This is the old way of doing it. This is the new way. So the key to using the string interpolator is you just simply put the $ before your string, and that will allow you then to embed your actual variables by name directly into that string output. So it's just simply a set of curly braces and then the variable name, and that's telling then the right line method, hey, go get this value and add it here into this string. And that in itself is actually helping us so we don't have to do concatenation like was demonstrated there in the previous video. Because it used to be what you would do here without the string operator and even without the older method we used to use, even before that came along, we actually had to put a quote right here after that comma saying that the word hello comma, that's the text we want to print to the screen. Then outside of the closing quote, I'd have that plus symbol, which is the concatenate operator. I'd say now display the variable text, and then I'd have another plus operator after that, concatenation operator, that would say now here's the next part of the string, and so I'd have something else typed out in quotes, and then you'd have to have another plus symbol if you wanted to add another variable value into that string, on, and that's what concatenation was all about, and still is. I mean, we still use it, but you know, if we can avoid it, it's just much easier to do it this way, because keeping track of the open and close quotes where the string values needed to go, and you know where you're putting in your variable values. It was difficult to track it all. And so this really makes life a lot easier. So get used to using that string interpolation method. And you'll have an opportunity to do that in lesson 5, because you're going to take input from a user, and you're going to want to output then the value that the user has input in a sentence, so to speak.